Okay, and here we go. Hopefully by now you've got Workbench up and you're ready to go. It's not a bad idea to save your SQL file right off the bat, just so you don't lose anything if anything crashes. Save early and often, as they say. Okay, we'll see how smoothly this goes or doesn't go. This is the stuff that I don't do it as often, so I'm more prone to make errors here and there when I'm doing DDL stuff, like data definition language. You do more queries than you do building of tables and databases. But yeah, it'll be all right. So there's just the 5 questions because a couple of them are kind of gnarly. And if you haven't done this stuff before, then yeah. So let's take a quick look over here at the perspective questions. So number 1, write a script that adds an index to the AP database for the zip code field in the vendors table. So if you've done your reading, then you know what an index is. It is simply a way to it's a way for the system to reference a single column and look something up by a single column instead of having to scan through the entire table. So older examples of index, so like where does this word come from? And I was trying to think of examples and I couldn't think of any examples like from the real world, like non-computer systems that you guys would actually be likely to know anything about just because of the generational thing, the stuff that I grew up with. You guys may not have grown up with, I don't know. When I was a kid, there was always a dictionary in the house, and we had kind of a poor encyclopedia set too. It was definitely better than having nothing. And when you wanted to look something up in the dictionary, there were a couple of different indexes that it had. One, it had an index in the back, so you could look something up by word, just in a big list, give you a page number, and then you could flip to the page. So it was easier than, you could do it by flipping through the whole book, right? It was all in alphabetical order. So if you knew the word you were looking up, you could find it that way. But it's just, sometimes it was a lot easier and quicker just to look it up on the index, grab a page number, and then look for the page number. So that's what an index is. That's the whole idea, is you've got a shorter, sweeter way of looking stuff up that you can then grab the entry that you're looking for. They also had a different kind of index on them. Let me just crack this open here real quick. Let's go to Google Images and see if they've got something here. So dictionary index with Python. See, nobody knows what a dictionary is anymore. Okay, so this is what I'm talking about. So alphabetical dictionary index. So this is where you could go and look up your word and look up the page number. But check this out. It also had a thumb index so that you could quickly and easily get to the alphabetical number, or not number, the letter.
I remember those.
Okay, good. I'm glad I'm not the only one. So a dictionary would have 2 indexes, right? And that's perfectly possible for a table and a database as well. You can have multiple indexes. There can be different kinds of indexes, like the word index and then thumb index over here. You've got primary keys. Those are indexes. Automatically, foreign keys are indexes. In addition to those, you can create an index that is it's neither a primary key or a foreign key. It's no kind of key at all, but it is another column by which you can look something up in the table. And so when would you want to do that? If there is another column that's not a key column, but which nevertheless you expect to have a lot of queries run on that column. You expect there to be a lot of queries looking up stuff by that column name or that column value or what have you, then that's the time to add an index. But you want to be judicious about it, because adding an index does add to the overhead of the system. It does slow things down ultimately. But if there is a column that gets looked up a lot, then that slight slowing down, it can be more than balanced. The only other example I could think of was, and you guys really won't know this one, you guys have probably never seen a phone book in your lives, right?
I've seen many.
Oh yeah? I guess they still deliver those sometimes. So you see the smaller ones in the driveway, and you just go ahead and recycle them right off the bat. But yeah, phone
Man,
books.
I think it's probably been a good decade since they deliver them by now.
Yeah, I was just thinking that as I said that. It has been a while since I've seen one. But they kept delivering them for like years after anyone wanted them. Like I would just immediately recycle them when they would show up, and I think that other people would do the same. But anyway, you could have an index in a phone book. You could also have a thumb index in like your own personal phone book, something like that. So same kind of thing. So those are the only two examples from the real world I could think of. That's what indexing is all about. So writing a script and adding an index, I almost skipped over this one because it's probably not something that's going to be required for your project, but you need to see it at least once. So, and it's simple enough to do. So let me pop on over to, oh, there it is, my SQL Workbench. And I think I'm still good to go. I don't think I've done anything to the textbook database recently. So let me just go open this SQL file here, and we'll go ahead and start with number 1. And the question here is, write a script that adds an index to the AP database for the zip code field in the vendors table. So this is if like they're expecting, yeah, we're going to be looking up vendors by zip code a lot. And so we'll go ahead and add this, even though it's not a key, we'll add this as an index. So it's going to be, let's go ahead and just start with our old friend, select all. Right? Select all from vendors. And I have to do use AP first. There we go. I don't like looking at my error there. And then we do the select all from vendors, and this is our old friend, right? We've been staring at this for a few months now. And these are all the columns, and here is the column in question, vendor zip code. And so what we want to do is just add an index to that. So before we do that, let me just show you how to find out what indexes already exist on this table so that we can then add ours to it and then go back and check and make sure it got added. That's why that might be useful. So this is a show clause, and you can do this to like there's the show table, show database, and so on. This is maybe the first time you've seen this one. It's going to be show indexes, plural, from, and then vendors. So it's very similar to select all from vendors, show index from vendors. Let's go ahead and hit Control Enter and take a look. And here they are. So we've got 4 indexes. That's more than I was expecting, actually. We've got the primary and the vendor name. It looks like it's an index as well. I would guess this is probably a compound primary here, but I haven't really looked. And then we know what these guys are, right? If you have FK in the title, in the name, then those are going to be foreign keys, right? That's what the FK means, and that's just the standard naming convention. So vendors FK terms means that, yes, we're in the vendors table, and this is a foreign key that's referencing the terms table. And then here's another one. We're in vendors, and there's a foreign key that's referencing the accounts table. And then the column names are here. Just remember that indexes and the column name are not the same thing. In fact, the only one of these 4 in which it's the same is vendor name. The rest of them are all different. So we've got those 4. And this is one hiding. No, that's it. So let's go ahead and add our index, and then we'll take another look at the show indexes. So just like creating database and create table and so on, it is going to be create index. And then we're going to tell it what name we want this index to be. So this name could be anything, but let me show you just kind of some of the standard naming conventions too. So it gets a little bit crazy with all of these underscores everywhere, but here's what it should really look like. So you've got the name of the table that you're in, and then the underscore, low dash, and then the column that we're going to be referencing, which is, unfortunately, let me just do this again, select all, vendor zip code. It's already kind of a verbose one that has 2 underscores in it already, but there we have it. So vendors underscore, vendor zip code with underscores, and then, sorry, IX for index. That's what you usually, oh, I'm putting this in the wrong place. That's not in show indexes. This is create index. I should have realized when I saw the semicolon. So create index, not show indexes. Sorry about that little blip. Create index vendors, vendor zip code IX. So this means vendors table, vendor zip code column, and index. don't do the control enter just yet. We have to tell it what, like, even with all this information, it doesn't know which column we want to use. We have to attach it to a column here. So we're going to use the on keyword just like when we're doing a join, and we're joining, measuring two columns against each other, comparing them on vendors, this table, and then in parentheses, the name of the column that we want. We want vendor zip code, like so. And that ought to do it. Create index vendors, vendor zip code IX on vendors, vendor zip code in parentheses. And I'm going to give it a try. Control enter. And it looks like it didn't have anything to complain about. So let me go back again, and I will do the show indexes from vendors. And here they are. There's the 4 that we looked at before, and now there's the 5th one that we just added. And there it is. It's on the correct column name. And don't worry about stuff like this, the collation, the cardinality just means like the number of unique entries and so on. You don't have to worry about that stuff right now. It's just extra details that may be useful someday, but for the time being, you don't have to worry about them. Okay, so that's it for number 1, and really it's just these 2 lines here. The rest of this stuff was just kind of, using AP and then checking our work up here. So these are the 2 lines that you want for creating an index. Questions about indexes, like what they are, how to create them, how to show them? All right, cool. Number 2 is the long one. This one has several different pieces and several moving parts. And you can just tell by the instructions, right? The ones that are a little bit longer are going to have a little bit more to them. So write a script that contains a create table statement needed to, statements, plural, needed to implement the following design in the EX database. And so it gives us a nice friendly little graph here about what it's supposed to look like. And then it gives some instructions down here. So these tables provide for members of an association. Okay, here's members. Each member can be registered in one or more committees within the association. Okay, so that's one to many going this direction. And then it's one to many going the other direction as well. So we did an example of this for chapter 10. I can't remember what the details are, but it was something, I think it was the number 3, whatever that was. I think it was like members in groups. It was like almost the same thing. And it's just that we did the ER diagram, and now we have to do it with coding. So yeah, basically one member can belong to many committees. So there's one to many going in this direction. And then one committee can have many members, of course, and that's one to many going the other direction. As soon as you have that, you have many to many. When you have many to many, that's when you use this guy in the middle. This is not a lookup table, as is commonly said, but it is a junction table. It doesn't have any data of its own. Both of these columns are foreign keys, member ID going this one, committee ID going this direction, and their only purpose is to join those 2 tables together, and that's it. It's for that one-to-many relationship, and it's the most convenient way to do it. Now, it was in the ER diagram, it was super simple to make this, right? We made these 2 table indications, and then we just dragged the many-to-many relationship, and bam, it just created this the junction table right in the middle. And cool, we were done. It's going to be a little bit more complex this time. And then after we do that, let's see. Well, we did a query on this. No, I guess that's for the next one. Yeah, okay, so this is the join query that we do on number 3, so we don't have to do that for number 2. The problem that I have with the way this is written is simply that it includes statements to drop the tables if they already exist. Okay, great. Thanks for telling me that at the very end, after I've just created these tables. This really should have been the first thing in this question. This is one of the rare cases in this textbook, which overall is very good, that I just, yeah, that bugs me. Do this part first, and we will do this part first. I'll show you how to get rid of these tables if they exist, and then create the tables, because that's the order in which you want to do them, really. So, dropping the tables first. Let's go over here. So this is number 2, and this is going to be drop table if exists. That's it. One of the things I like about MySQL is that it's so close to English. It's one of the things I like about Ruby too, and there's a lot that I don't like about that language, but it reads like English, which makes it friendly. I like that. So we've got members, like so, and unknown table AP. Oh wait, I got to use EX, but that's okay. It just gave me a warning. It didn't give me an error. But yeah, I think that all the rest of these are going to be the EX database. So you might want to go ahead and do a use EX, or as you know, you can just double click on the database name over here. So drop table of exist members. There we go. It's giving me a warning, unknown table. Yeah, I know. That's why I said if exists. Let's go ahead and do the other one. And you can just copy and paste and change the name of the table if you want. But I'll type it out. Drop table if exists. And this is going to be committees. There we go. It gives me another warning. And then drop table exists. And then the junction table is called members underscore committees. This one's going to be irritating to type out. I'll just go ahead and give you a warning about that right now. There's a lot of committees words everywhere. Members, committees. There we go. So there's your 3 drop statements. Drop table if exists. These are very commonly used for a script that creates a database and then creates new tables for the database. If you take a look at that SQL file that I gave you to start the final exam or the midterm exam, after creating the database, we had statements like this to drop table if exists, like Baroque Orchestra and Classical Orchestra and so on. Just in case they might happen to exist already, you just get rid of them and then you go ahead and create them. It's just a safer way to manage it. Even if you don't see any situation in which they might already exist, just go ahead and throw them in the beginning of the script. So I think that's why they have us do it. Just put the instruction in the wrong place, that's all. So got that done. And let's go ahead and make these tables, first of all. So the 2 easy ones are going to be members and committees. Those are just pretty straightforward. Member ID and committee ID are both going to be your primary key columns. And then the rest of these are just going to be variable character chart. We'll do varchar 45 since that's what was showing up in the ER diagrams and so on. Maybe we'll do an integer for the phone. And that'll be it. So that'll keep things simple. There are other things that you probably want to put in here. For instance, if you didn't want the last name to be nullable, which you probably wouldn't, you'd probably want your members to have to put in the last name. But we just won't bother with any of that stuff. We're going to keep it simple because it's already gnarly enough. So let's go ahead. So the first one we're going to do create table. And this is going to be members. This is the first one. And you get this kind of code block, and you often see stuff after the closing parenthesis here before the semicolon. And this is where you specify things like, the database table engine, like engine equals NODB, and then you can specify the default character code like UTF-8. But again, we'll just keep things simple for right here. Now, when you do a create table and you have the code block in parentheses, you got to give it a list of things, right? At least one, and in this case more than one. And the list of things is the columns that you want in the tables. And then you put in any information that you want to about those columns, or that you need to, I should say. The only thing that it demands, well, 2 things. It demands the name of the column, and it demands the data type as well. It can't handle it with that. It's not JavaScript, right? It needs a data type. So, and then of course for like the member ID for the primary key, we're also going to tell it it's got to be an integer, it's got to be not nullable, it's got to be auto increment, and it's got to be the primary key. So let's start with that. So member ID is the first column. You guys know how I feel about this naming convention. I prefer just to call it ID because we're already in the members table. We already know that this is member ID. But anyway, there are different coding styles. So it's going to be an integer. It's going to be, it's going to be not null. And it's going to be auto incremented. So that's how you type that one in, auto underscore increment. And then primary key, which I always wanted to do like this, but that's not right. It's 2 different words. It's because you can also have a foreign key, so that's why key is a separate clause word. Okay, so this is the first column. We'll put in the other columns. The columns are a list of things. They need to be separated by commas. So there's our first column. The next one is first name. Put these in the order they were requested. And this is the one that I'm going to do the varchar 45. And so many of these are going to be a variable character with 45. I'm just going to grab this and copy it so that I can just keep using that over and over again. I recommend that you do the same thing. So I'm just going to kind of slam these in, and then I'll pause for a little bit. So next one is going to be last name, and I'm pasting in the varchar 45. There we go. And then what do we have? Address. If I were being strict with myself, having this as an address doesn't make sense, right? We just learned about why you would want to take an address and break it up, right? So that it passes normalization. You'd want to have like the street address in one field, and then you'd want the city in another field, and so on. Oh, actually, never mind. It is doing that. I just got confused by how few the columns are. Like, there's no zip code in here. There's no like street address number 2 or anything like that. It's kind of a simple. Let me make sure I'm doing this right. Hang on a second. Okay, first name, last name, address. Yep, that's it. Okay, so the reality would probably be a little more complex than this. You'd probably have a few more columns than just this. Let's see, city, varchar 45, state. There are probably better ones, but I'm just going to go on. It didn't say anything in the instructions about what data types to put in, so I'm just kind of slapping some in here. I'm simplifying as much as possible. And then, you know, if you wanted to at least be a little strict with yourself, maybe make this an integer instead of variable character, right? So this
For
is...
mine,
What's that?
for mine, I just made them all text. Is that fine, or is that would that need to be changed?
It should be okay. I recommend using variable character for most things, but it should be fine for now. There are, by the way, there are different kinds of text too. There's like medium text, long text. I think there's tiny text, but you wind up seeing variable characters a lot more often.
Okay.
But yeah, I don't expect it to cause a problem. Okay, hopefully you guys have all these, and I'll just let a little bit of the cat out of the bag. If you don't, I don't think we use these guys in any of the further questions. I think we only have to worry about member ID, first name, and last name. Could be wrong about that, though. But in case you're a slow typer and you're not able to keep up, then at least get the first 3 in, because I think that's all we need. So I'm going to go ahead and do the Control-Enter thing. And you guys know me. I look for the green down here, or at least yellow, and then I go ahead and do a select all. I just like to see that it exists, even though I know there's no data in it yet. I just want to see that the table exists and that the structure of the table, by which I mean the columns, is like what I expect, and looks like it's fine. So we'll go ahead and do the next one, committees, which is much simpler. But the syntax for creating the table is exactly the same thing. Create table. This one is going to be committees. Now watch out as you type these. Committees has 2 M's, 2 T's, and 2 E's in it. I'm saying that because this is the sort of thing that I often will misspell because I'm typing too fast. I'll miss a T, or I'll miss an M, or sometimes an E, something like that. So I'm going to type this one carefully, or maybe do some copying and pasting it in. So this is going to have, remember the code block in parentheses, semicolon. Oops. There we go. Once again, we need the primary key, which in this case is committee ID, and the committee name will be that varchar again. So committee ID, and this is going to be our old friend, int not null, auto increment, primary key, comma. Make sure you're putting commas in between the items of the list. And then the committee name. varchar 45. And do not put a comma after the last item. You can do that in JavaScript, but you can't do it here. Or in most other programming languages. Okay, so it should be looking like something like this, and should be able to type that a little bit quicker than the last one. I'm taking the opportunity to double check my committee spellings everywhere. Okay, Control Enter, seeing green. I will do my little select all from committees to check my work. And there it is, just 2 columns, no entries so far, good to go. Okay, so here's the gnarly part, is doing that last table. These guys were all very straightforward, right? Even though this one had, you know, more than a couple of entries, or sorry, columns, and then this one only had a couple, simple to go. So now what we're doing is we're doing this middle guy right here. And this is the one that was so easy to do in the EER diagram, and it's going to be, it's going to be a little crazier than that when we have to code it in. And it's going to start out looking super easy. Like we start out with just doing these columns here. And so it looks like it's going to be like the same thing as this, but then we have to add a couple other things. So here we go. This one is going to be create table, and the name is members underscore committees. And this is common naming convention if you've got a junction table between 2 other tables, right? So one is members, one is committees, and the junction table is called members committees, or it could be committees members too, it doesn't really matter. Code block. And this one, in fact, is going to look even simpler than committees at first. So we just need the 2 columns, and they're both going to be foreign keys, so we don't even need to create a primary key, which is what makes it seem simpler. Like we don't have to add all this stuff in here, right? We just need to do the 2 column names, give them a data type, the member ID, members ID, yeah, members ID. Wait a second. No, we don't want that plural. We want member. Let me make sure I did this right. Yeah, member ID. Okay, cool. So we'll have the member ID and committee ID in here as well. They're both going to be referencing the primary keys of these other 2 tables. And so all you need in that case, remember, the only thing that's really insisted on is that we give a column name and a data type. These are both going to be integers. So member ID, it's going to be an int, and that's exactly where we can stop. And then committee ID. See, I misspell that word all the time. Committee ID, another int. Okay, so don't hit Control Enter yet because we're not done yet. I mean, okay, so you could. You could, if you like accidentally created the table and you didn't feel like uncreating it later, then I mean, you can add foreign key constraints to existing tables. But in this case, let's just go ahead and see what it looks like when we add all this in here from scratch. I have to make that a little bit smaller. And I am going to make this disappear down here. And my favorite way to do that is just to throw an error. Gets rid of that, and we'll bring it back up next time we run a query that's successful. Okay, so you should have the members committees table, a member ID column, and a committee ID column, both of which are ints. We're adding constraints here instead of other columns, but you still treat them as items in a list. So that means you give it another comma. And this is going to be constraint. Now, by the way, and I'm not even sure what the solutions for the textbook gives on this. It may just say, you know, instead of putting the word constraint, it might have you just say like foreign key. So you're just adding a foreign key column and referencing another column in another table and so on. But when you add, when you use the keyword constraint, instead of just jumping right for the foreign key clause, that means you can name your constraint. You can give this your own name. If you don't, then the system will name it for you. So sometimes it's handy just to already know ahead of time what your indexes are going to be named. And the way you can control that is by using the keyword constraint. So that's the difference here. So let me show you what one of these looks like, and then I'll show you what it would look like without using the constraint clause. So we're going to name this index here. It's going to be a foreign key. And we're going to call this is where it starts getting a little bit crazy. Remember what we do. We do the name of the existing table or the current table, the referencing table, and then we use the FK, and then we say what table we're referencing with this. So let's go ahead and do this one. The name of this table, and you guys go ahead and copy this down. I'm going to type it in, slow myself down a little bit. So member_committees, that's the name of the current table, and then _FK, foreign key, and then underscore, and then the name of the table that this is referencing. So we're going to need two of these. First one's going to reference members, which is the first big table that we made up here. So this is a fairly standard naming convention. So, and then after that, the foreign key clause. And we're going to tell it what column we want. Let's see. It's going to be this one right here. Remember, we need to do both of these.
Did you forget a comma or?
No, actually, there's no. I'm still on the same Uber clause here. If I put a comma here, then I believe it would create the constraint, but it wouldn't give it any key information or attach it to a table or anything like that. So I'm still continuing the constraint statement here. So the foreign key, I'm going to attach that to this member ID column here, and you can tab in or not depending on how you like it. References, we're going to tell it what table it's referencing, which is members, and then the column in members that it's referencing, right? It can't reference the whole table, it's got to reference a column, and it's going to be the primary key as it, I want to say it's not quite always, but almost always. There we go. Okay, don't hit Control Enter yet. We're still not done. So this is here. So I'm specifying, we're creating the two columns, and then we're saying, okay, we want to add a constraint to this table. Here's the name of the constraint. And then it's going to be a foreign key constraint, and we're going to put it on this column here, which is what that does. And then what table is it referencing? It's referencing members, and it's referencing the member ID column, this guy way up here, of members. So if this looks crazy, well, it kind of is. It takes a few times to kind of get the hang of this. Now, again, don't hit Control Enter yet. We still got to go further, but I want to show you right up, and don't do this. Just kind of take a look at what I'm doing. I'm going to remove this whole line 39. Well, where it says constraint and member committee, members, wait a second. See, I'm glad I did this because I misspelled it. It should be members committee. It should be the same name as this guy right up here. So if I get rid of this line here, you can do it like this. But the thing is, you can add a foreign key and you can attach it to the column and you can reference another column in another table and go through all that stuff, but you don't get to name your constraint. There's no functionality in here for naming the constraint unless you use the constraint keyword first. If you do, then you get to name this guy and you know what your own naming convention is, or your team knows what its naming conventions are. Maybe it even has a style guide about what to name indexes and so on, or constraints. And so yeah, that's the point of using the constraint keyword. Like I said, I don't know if the author does this or not. But that's the point, because very often you will see it the other way, where it just says foreign key. It doesn't even include this constraint clause. But that's the point of doing it. So, as I said, we're not done yet. We need another comma. This whole thing is the constraint statement. And we're going to do the whole thing over again. Remember, member ID, this column is the one referencing members table. We also need one that's referencing the committees table. So let's put in another constraint. You can copy and paste if you want to, and if you trust yourself. I often don't trust myself. Okay, naming convention. The current name of the current table, which is the referencing table, members, committees, and then FK. But this time, instead of underscore members at the end, it's referencing the committees table. So we'll put committees here. Starting to look a little ridiculous, isn't it? If you were writing your own variable names for a procedural programming language or a functional program or something, I doubt you would use ones that were this verbose. It's likewise going to be a foreign key constraint. This one is going to be on the committee ID column. And it's going to references committees. And then on the committees table, it's going to be referencing this committee ID column. Getting tired of typing committee yet? This is what happens with this stuff. I mean, naming in MySQL or any kind of data structure language, I think, is just, it's verbose stuff. I think it kind of has to be. So let me do a look over this. Table committees, members committees, member ID int, ID int, and that was the easy part. And then creating the toConstraint is what adds all this stuff. Members, foreign key member ID, foreign key committee ID, references members member ID, references committees committee ID. I think that's right. I'll let you look at this for another moment, and then I will go ahead and try executing it and see what happens. And if it doesn't work, you can certainly interrupt and ask me to take a look at your code. But keep in mind, there's also the recording. So you can always go to the recording later on and watch it, or take a quick screenshot of this if you'd like. All right, I'm going to go ahead and hit Control Enter. I'm seeing green. I like it. And of course, we can do our old friends select all from. And this is going to be members underscore committees. And there we go. There's just the two columns, and that's it. No primary key or anything like that. Let's go ahead and do our show indexes from members committees. And there's our two foreign key columns that we created. Member ID and committee ID. And yeah, it's in the same two. Yeah, it was looking good. Looking fine. So that's it for, is that right? Yeah, that's it for number 2. So that one took a little bit
My
more.
hand's starting to hurt already.
I'm sorry? Yeah. Don't worry. I mean, I think this is the hardest part of these 5 questions is number 2. Number 3 has a lot of sections to it, including kind of a gnarly join, like a double join. But I consider this is the toughest part of here, especially since it's new stuff, right? So yeah, number 1, which was this guy, pretty simple in comparison, right? Number 2, whoa, crazy, oh my god, full of stuff. Okay, cool. So got through it. And you guys know my advice on this. I know you were following along with me, but if you want to get a handle on how it works, just type it a bunch of times. Like seriously, delete it, type it, see if you can figure out what's going on, do the select all, do the show indexes. Does everything happen the way expected? Okay, just still don't understand. Okay, delete it, type it again. Just keep doing that over and over again. It really is about dirt time with this stuff. Okay, let's move on to number 3. We're doing great. Number 3, and this is where we're going to insert some values into these tables that we just created, members and committees, and then we will do a select query with a double join to just see what it looks like. So this is insert into, and this is one that we learned back in chapter 5 last semester. Insert into is where we can add entries to a table. So insert into, and you might recall that you actually don't even need the into. I think it's just coding style. I've always done it that way, so I keep doing it that way. But you could just do insert, and it works fine. So we're going to be inserting values into members first. So let's take a look here. So number 3, add 2 rows for the members table to the members table for the first 2 member IDs. It doesn't tell you what data to put in there, right? So we're basically making up stuff. So I guess this is that data entry that I was talking about before. But I'm going to kind of cheat a little bit. When we created these tables, we didn't make any of them not null except for the primary keys. And so we can just do the ones that we feel like, and we can leave the other ones out, and then we'll just have null values in there. And to figure out which columns we really need, I'm looking forward a little bit. And the select statement with the joins is asking for committee name, member last name, and member first name. So other than the primary keys, I think that's the only ones we have to worry about. So I'm going to put a primary key and member last name and member first name into members. And then committees, I'm just going to put in the primary key and committee name, and that's it. If that's confusing, then go ahead and put in all the values. It's fine. That's probably what the textbook author wanted us to do, but again, I'm going to cheat a little bit and make things a little bit simpler. So let's go ahead and insert into members, and since I'm not doing all of the columns, I'm going to go ahead and tell it which columns I want. I'm going to insert in member ID, and I think it was just first name and last name. Is that right? Hang on a second. Let me look at members again here. So call for members. So yeah, we've got first name and last member ID. Yeah, that's it. Okay. Member ID, first name and last name. And then values. And we're doing 2 entries here. So as you guys might recall, it's going to be a pair of parentheses for each of the 2 entries that we do. So I'll go ahead. Sometimes I code out all the punctuation first just to get the kind of structure in there. And then the first set of parentheses, again, it didn't tell us what to do, so we can put anything we want to. Just remember that for the auto, we do have to put some value in for the primary key here. Although actually, now that I think about it, we could just do first name and last name, and it would auto increment on its own. So, let's go ahead and try it. Well, you know what, I already started this way, so let's go ahead and keep this. But I wasn't really thinking straight, but yeah, you don't actually have to do this, what I'm doing right now. If you're including a value for an auto,
I was just about to say that.
Yeah, you actually don't need
Like, couldn't you just use default?
Yeah, I was going to use default here, but what I was saying is that you actually could, since it's an auto incrementer and it'll add it on its own, you actually don't even need to put that in at all. You can just do first name and last name and then just put those 2 values in. But I don't want to change too much up on you guys midway through, so go ahead and put default, and then make up your own first name and last name, whatever you want. Keep it reasonably appropriate. Remember, I'm going to be reading these. So I'm going to do Mickey Mouse. Now, Mickey is the first name, and Mouse, I think, is the last name. And then I'll do another default here. It's inside the parentheses as well.
Be careful with that Mickey Mouse.
Yeah,
the House of Mouse don't play games.
I'm going to get sued real quick here if I'm not careful. I better do something from Warner Brothers this time instead, just to mix things up. So I think Daffy Duck is from Warner Brothers. So Daffy and Duck is, of course, the last name. So this is just the first part. This is all it wants us to do, really. Well, like I said, it probably wants us to put all of all of the columns in, but I'm just going to leave these. We don't know the address or the phone number of Mickey Mouse or Daffy Duck. You can put your own names in there. Oops, missing a comma. That's by far my most common error. Is either an extra comma or a missing comma. And then right after that is having a semicolon where it doesn't belong. Okay, I think that looks good. I'm going to go ahead and execute, see if it works. I got green. And then if you want to, go ahead and do select all, just so we can check it from members. And there we go. There's Mickey Mouse and Daffy Duck. So that's simple enough. That's last semester stuff, right? So 2 rows to the members table for the first 2 member IDs and 2 rows to the committees table for the first 2 committee IDs. So same thing. Make up your own committee and insert it into committees. So this time let's do it the other way and not bother with the primary key. So all we need to worry about is the committee name, and that's it. So I'll do insert into committees, and we're just going to do committee name. Values, we still got to be in parentheses here as far as I know. Oh, actually, yeah, we're going to have 2. So just like before, right? It asked for 2. 2 rows, yes. So again, make up anything you want to, be reasonably appropriate. I'm going to say chess club for this one, and guitar ensemble. Sound more like groups than committees, but I'm going to stick with it. So notice the difference here. In this one, I foolishly added in the member ID, and that means that we have to actually put the default value in here. But this time, I'm just putting in the committee name, and that's it. And so the primary key should auto-increment on its own. That's what I wasn't considering when we did the first one. So you can do it either way. It doesn't really matter. Control Enter. It likes it. Let's do a select all and make sure that I was right about that. Select all from committees. And there we go. So it auto-incremented for me. So that's kind of the point of auto-increment. So we don't have to go through that whole default thing. So there we go. I got chess club and guitar ensemble. We got the committees in there. Good to go. And excuse me, now we're going to insert some values into the middle table. Committees, members committees. Now this one looks longer, but it's actually really simple. We're just going to put in values 1, 2, and then 2, 1, and then 2, 2. That's it. So here's what it looks like here. Let's go ahead and do insert into, and this is the painful table name, members committees. Let's see. And yeah, it's just the 2 values. So let's go ahead and do, we don't need to give it the column names or anything. Values. And we're going to have 3. So again, if you feel like it, you can do the punctuation beforehand. I know sometimes I do. Sometimes I feel like it to be helpful. Sometimes I don't bother. I do that with procedural programming too. If I'm having trouble figuring out the logic of a function.
I think I've fallen a little bit behind.
Oh yeah, okay. Where do you want me to scroll to?
I got the insert into committees and I just finished putting in the values. So go up a little further. Okay, so I need to insert into members committees.
Oh, okay, cool. Yeah, that's just where I was at too. So I was just saying that sometimes this can be handy in procedural programming. If you're having trouble figuring out the logic of the code block or function or something like that, try putting in all of the loops and conditionals and organizing those before putting the actual values in or figuring out which ones need variables passed and so on. Sometimes that can help.
Hey, Mr. Luke.
Yes.
By any chance, are you using a laptop?
I am. Why?
So, you know how when you type and like you could go like middle of a word and then like kind of type in more, but on mine I accidentally pressed something. I don't know where the keys are of the laptop, and it just types over the letters.
Yeah, it's the insert key.
Yeah, I can't find it. That's the. Like,
it should be the letter. It should be the numeral 0 on your num key, on your numpad.
So just control or like.
No, just
0.
Hit the 0 on your numpad, or maybe it is control. I don't know. I know there are times when I accidentally hit. Does anybody know? Is it control insert or function insert or something?
Okay, that worked. Okay, yeah. It's 0. I just pressed it by itself.
So it wasn't like you didn't have to hit like FN
no.
control or anything?
No, yeah, I didn't have to press anything, just 0.
Okay, cool.
Thank you. It was bugging me this whole time. I
Oh,
couldn't
heck yeah.
like go
I remember the first time I ran across that, and I had no idea what was going on.
because I remember that happened to me a long time ago, but I was on my PC, so I had
Yeah.
my keyboard. Even he showed me, I was like, okay, I know where that key is. I'm trying to look all over my laptop, and I just can't find it.
Yeah. It seems to me that these Windows keyboards have a bunch of peripheral keys that you dare not touch, right? And if you happen to accidentally touch one, it does something crazy. Like in my case, at the beginning of last semester, it like turned off my camera, and I had no idea what the problem was.
Yeah, I
Or,
remember that.
yeah,
Last time I had a laptop, one of the biggest things I would run into is every time my cat would walk over the keyboard, they would turn it in. They would turn on airplane mode every time. I never knew what keys they were stepping on to activate it, but every time they'd just turn on airplane mode, which sucked for me because I was usually playing some kind of online game.
cats are just going to cat. That's what they do.
You know, I knew somebody who cracked the code
Oh,
to get a dummy keyboard, and the cat won't step on the keyboard you're using.
wait, so you do what with the keyboard?
You get an extra like $5 cheapo or something you got stashed away, and you use that as a decoy keyboard.
Ah, I get it.
You
Smart.
leave that out in the open, and you have your actual keyboard down below.
That's very cool. Yeah, cats think they're smarter than us, but they actually are not. Okay, let's get some values in here. So ones it asks for, it's just 3 simple entries. 1 and 2 for the first one, 2 and 1 for the second one, and 2 and 2 for the third one. So that's going to be these guys. They're just integers, right? 1 and 2, 2 and 1, 2. Okay, so 1 and 2, there's the first one. 2 and 1, there's the second one. And the third one is 2 and 2. Easy peasy, right? Well, I mean, once you've got that junction table created, I mean, entering values is really easy. It's just creating it with that double foreign key that looks frightening the first time you see it. So I think this will do it. I'm going to do Control Enter. Shaboom. Seeing green, happy. And if you, I probably don't need to this time, but if you want to, yeah, you can do a select all from members committee, or if my font were a little bit smaller here, I know I've got that upstairs somewhere too. I just be scrolling to get to it. So there they are. Yeah, 1 and 2, 2 and 1, 2 and 2. So these guys, of course, are referencing the members' primary key. These are referencing the committee's primary key. And so what it's saying here is the first member belongs to committee 2, right? And so Mickey Mouse belongs to the guitar ensemble committee, right? That's what that's saying. And then number 2 is a member of committee 1. So Daffy Duck, I think, is a member of the chess club. And then the last one being 2 and 2 means that Daffy Duck, the second one, is also a member of the guitar ensemble with Mickey. So that's what these guys are doing, right? It's just the junction that's there to match up primary keys from those other 2 tables and to get that many-to-many relationship. Okay, so now is the big select statement. Although, again, this is nothing you guys haven't seen. You guys did compound joins last time around. Let me go ahead and just put the blah in there again so we can... I'm sure there's a better way to do that, but that's the way I've always done it. Okay, so our old friend select, right? And here's where it tells us, oh yeah, we want committee name, member last name, and member first name. So that's all we need. So committee name, is it last name? Yeah. And first name. Now, what order should you put the tables in? It really doesn't matter at all. Unless, I mean, it does. I mean, what matters for the result table is what order you've got these guys in. As far as what like the order in which they're joining, it really doesn't matter. I tend to use for my from clause, I tend to use the table that happens to contain the first column that's being asked for. and then I join the other tables, in the order as needed. But like I said, it doesn't matter. So I will do a committee name as in committees. So I will do from committees, and then we got to do a join. Now here's where you might think, okay, so last name and first name, hey, those are in members, right? Wherever those wound up here, way up there. Okay, so this is in members. So all I have to do is join committees to members, but we can't do that. We've got the junction table connecting the two, right? We can't set up a many-to-many relationship without that, really. And so what we have to do is we need to take committees and join it to the junction table members committees and then join that to members, right? So again, you guys have done this before. It's just that this time it's working with a different kind of relationship with the junction table. So instead of joining members here, we're going to join members committees. And I think that we'll probably want to stop typing committees at some point. So we'll probably want to give these guys aliases. Members committees, MC on, and there's a committee ID in both of these. That's how we compare those two together. So on c.committee ID equals mc.committee ID. Hopefully this is starting to look a little familiar to you. And then we need to join, so now we've got the junction table. Now we need to take that and join it to members, right? So committee gets joined to the junction, and then the junction gets joined to members, the other table. So another join clause, and we're going to join members this time, M on, and this time it's going to be member ID. There's a member ID in members committees, and there's a member ID in members. So on mc.member ID equals m.member ID. And then just because the textbook author likes to do this, sort the results by committee name, member last name, and member first name. So that's the last thing I'll put in here. I'm going to do an order by. And then actually I can just copy these right over. Paste and semicolon. I'll leave this up for just a moment before we try executing it. I can't remember, did we do a triple join last semester? Oh no, I remember. There was one that the question made it look like they wanted a triple join. I think that was chapter 6, but they didn't actually need one.
Could have sworn we did at least one.
What's that?
I could have sworn we did at least one.
Well, maybe we did, and I just can't remember it. Calling my memory a leaky sieve would be kind. Okay, I think this is right, unless I misspelled committee somewhere, which is certainly possible.
And I wish my memory was a leaky sieve.
Yeah, right? Me
At least
too.
it would hold a little.
Okay, let's try it. Full enter. Oh, green. I like green. And there's our results table down here. Committee name, last name, first name. And yeah, we've got these guys going on. So this shows that Daffy Duck is a member of Chess Club and Guitar Ensemble, and Mickey Mouse is only a member of Guitar Ensemble Committee. And that's what was achieved by entering these values into members committees. These are the results of that. Okay, so that is number 3. You guys ready to move on to number 4? Number 4 and number 5 are going to be short compared to these last two.
Man, that was only number 3. I thought that was at least part of 4.
Yeah, 2 and 3 are, yeah, they go on for a bit, don't they? But the first one was short, and number 4 and 5 will also be fairly short at least. Let's do number 4 here. And so instructions on number 4. Write an alter table statement. So yeah, it talks about like the name of the chapter is creating databases, tables, and indexes, but there's other stuff in there too. Altering table is modifying columns. There's adding columns. and those kinds of things. It's all DDL language, right? Except for that select statement and the insert into statement. The rest of the stuff is data definition language. So alter table statement, it has two new columns to the members table that we created up there. So there's what, like 5 or 6 columns already. We'll add a couple more. One column for annual dues, and it has you do a decimal, and then you want to put in a default value, and then another column for payment date. So let's go ahead and do that. So this is going to be a piece of cake compared to those other two. The alter table, easy peasy. Got to tell it the name of the table. We're modifying members. And what we're doing is we're adding a couple of columns here. So we've got one, that's the annual dues, and it's got to be decimal. It tells us how many digits to use, and it's got a default value. So we're going to do add column. And this is one of those things like insert into. You don't actually need to include the keyword column on this. You can just say add, because there's nothing else it could really be. But I tend to do it this way just because. Let's see, the first one is annual dues. And it's going to be a decimal, which actually is, it's not even really a data type, it's a function here. But what it says is, it says 3 digits to the left of the decimal point and 2 to the right. So you might think, oh, okay, well, I'm going to do 3, 2. It actually doesn't work like that. You get the total number of decimals, total number of digits, I should say. 3 plus 2 is 5. And then the second argument is the number of digits after the decimal point. So it's going to be 5, 2 instead of 3, 2. And then to give it a default value, super simple, just say default. And then tell it what they asked for, 5250. And then we're going to add another table, or sorry, another column here. So comma, right? It's a list. And we'll do another add or add column, depending on what you prefer. And this one's going to be payment date, did it say? Yeah, payment date. Didn't tell us to format the date any which way, so let's just go ahead and give it a date data type. I mean, technically it's that, but we can just go ahead and leave it like this. And add column, annual dues, decimal 52, default 5250, add column, payment date, date. So let's go ahead and try it. Control Enter. There we go. It likes it. And as you guys know, I like to do my little select. There we go. So we just have the 2 entries, right? So we just added annual dues and payment date. Annual dues, it put the default number in. And then payment date is null because we didn't say not null. We didn't enter a value for it or default value or anything like that. So there's another way. This is already done. Like we're already done with number 4 here. But I just want to show you like this up here, what we just did. There's another way to do it. So, and some people would prefer this way because it's a little bit less verbose. So if you do an alter, not later, alter table members. I'm not going to execute this one. I just want to show you. So alter table menus, and then either add or add column. I'm being less verbose here, so I'll go ahead and just do add. And then you can put the 2 things in here. So I could put in the annual dues. What is it? Decimal 5, 2, default 5250. And then comma, right? It's a list of things. And then the payment date and date. So you could do it like this instead. This is one way to do it, like this. This one has more actual typing in it. This one has more white space in it. I don't suppose either one's easier than the other, but you should just see both of those. So you can choose your own, your own coding style for those. I tend to do it. I think of like MySQL SQ languages in general as being very declarative languages. It's almost like writing in BASIC or something like that. And so I tend to use fewer of like code blocks and stuff than other coders might. Anyway, that is another way to do it. So, but you only have to do one or the other, so we're done with that one. We're going to go on to the very last one, and you guys will have a much deserved break. So this involves modifying one of the tables, or sorry, I keep doing that, modifying one of the columns and committees to create it so that values must be unique, which we did not do when we created the table. So if we go over here, alter table, modify this committee's table, create an exercise 2, so the committee name in each row has to be unique. And then test it by trying to put in a duplicate name for one of the committee names. So I will do either chess club or guitar ensemble and try to add it. And if I do my job right, it'll throw an error message because I can't add a duplicate value. So if the column has been specified as unique. So let's go ahead and do another alter table. This is the last one. Alter table, and this is going to be committees. And it's going to modify clause. So modify, and what it said was to take the committee name column and make it so it has to be unique. So committee name. And what I really want to be able to do is just add this on. Like I say, just take everything that I've already told you about this column and just add unique to it. It doesn't work. You got to basically just redo the whole column here. So I have to once again put in varchar 45 or whatever it is that you put in for yours. And then you can go ahead and add the last bit that you need. So unfortunately, you have to put that stuff in there. I've never been able to figure out why they did it like that, but did it that way they did. So let's try it. So alter table committees, modify committee name, varchar 45 unique, control enter, seeing green. And, you know, we could do a select all from committees, but it's not going to look any different from last time. Let's try adding in like a duplicate value. So up here, let me check the values that I got again. I got chess club and guitar ensemble. So let's try to add in chess club again and see what happens. So insert into committees, values. Oh yeah, let me tell you. What is it? Committee name. Values, and then chess club. Like so, and I should get a fat error message right down here about having already a duplicate value. So control enter, and error, duplicate entry chess club. So that's what happens when you add the unique clause or the unique keyword to a column, is that you cannot enter duplicate values. I mean, in an auto-incrementing primary key is also like every value has to be unique, but it's done automatically, so you don't actually have to type in unique for that. As long as it's primary key, it's auto-incrementing, it's integer, and all that good stuff. So that brings us to the end of everything. I'm going to save this. So can I just control S, or is that for a model? No, it's saving it. Okay, good. And what are we? We're unit 3 now. And my little naming convention here, Bispo chapter 3.sql, and I'll save it in there. So like I said, I forgot to put up a submission folder for you guys. I will do that on the break. And then if anybody wants to go over any part of this again, then I'll be happy to. I'll leave this up so we can just quickly take a look if need be. And yeah, any questions before I stop the recording here? All right, you guys, go ahead and take a break. I'll see you in 10, and we'll have at least a little bit of lab left after that.